If you're already subscribed or you're already a subscriber, thank you so much. I love you this much. Mwah. And if you're new here, make sure to like, comment, and also subscribe. Yeah. So let's dive right into what we have here today. So we are going to be learning about calculus, specifically differentiation today. Differentiation. And in differentiation, there are different rules that you need to learn about when it comes to differentiation. But they were starting off from the basics, which is the power rule, which is the very first rule. The very first rule. And before we go to power rule, what is differentiation? Differentiation is simply the rate of change in anything, in everything you can think of. That's simply differentiation. And what does power rule state? The power rule of for derivative states that for any real number n, the derivative of x to the power of n with respect to x is simply n multiplied by x to the power of n minus 1. What does this mean? This simply mean, let me use my highlighter here. This simply, I'm here now. This simply means that what? The exponent which is x, which is n rather, comes down here, multiplies the base, and then you reduce the exponent or the exponential by, reduce it by 1, and you have n minus 1. That's simply it. Then the case whereby a constant is being multiplied by the base, that is x, what do you have? That's what we have this year. So that simply says that what? Once you have a constant multiplied by the base, it becomes the constant. Then remember that the exponent or the exponential, the figure in the exponential comes down, multiply the base, and then you also reduce it by 1. That's just difference between this here and this here. That's just difference. So to drive home our points, we have some examples here that we need to look at. So if you look at this example here now, we have that example 1 says y is equal to 7x to the power of 2. We are asked to find dy dx. Derivative means find dy dx. That's what it means. So if we are to find dy dx, what are we expected to do? We are using this particular one for constant. So our constant here is what? Simply just 7. And our exponent here is what? 2. So remember that you multiply the exponent by the constant. Then you reduce the exponent by 1. That's all. So what do we have? So dy dx is simply what? 2 by 7. And then I have what? X. Let's put this in a bracket. X. Then what? 2 minus 1. So my answer is simply what? 14 x to the power of what? 1, which is simply the same thing as what? 14x. I really do not have to put a 1. I'm very correct. The next one, we have y is equal to 8x to the power of 3 plus x minus 4. Now, if you look at this now, we have about how many entities here? We have 3 entities. We have 8x to the power of 3, we have x, and we have 4. So how do you treat this? You differentiate each of them, like using the power rule, each of them, then you bring it together based off the sign that's in between them. So if I'm going to differentiate 8x to the power of 3 using power rule, that will simply be what? That will simply be, remember, it is the exponent multiplied by the constant. In this case, the constant is 8, the exponent is 3. So I just do 8 by 3, then x to the power of what? You reduce the exponent by 1. So I have 3 minus 1. That's for that. Plus, in the case of x here now, the exponent here is what? 1. There's an invisible 1 here not written. Also, the coefficient here also is also 1. Or just, let's do it this way, such a way that we say that we bring, what's it called? The exponent down, it multiplies the base. So if I bring my 1 down, so this becomes 1 multiplied by what? My x. Then remember there is a 1 here, right? So I just do 1 minus 1. That's that. Then minus, in the case of 4 here now, you need to understand that the differentiation of a constant, 4 is a constant, is 0. But I'm going to show you how it is 0. How is it 0? For this 4, it can also be written as 4x to the power of 0. Why can I confidently write it as 4x to the power of 0? Because I know anything raised to the power of 0 is 1. Since anything raised to the power of 0 is simply 1, and 1 multiplied by 4 will still give me 4 back, so I can write this as this. So if I'm following the rule for power rule for this now, this simply means what? I multiply my exponent by my constant, which is 4. So it becomes what? It becomes 4 by 0. Then I have my x to the power of what? 0 minus 1. Now let's now simplify this and make it like come together. Then what do I have here now? So this is simply 8 by 3 is 24, right? Then this is x to the power of 2 plus this is 1 times 1 minus 1 is 0, right? And anything raised by 0 is simply 1. So 1 times 1 is what? Just 1 minus 4 times 0 is 0. 0 multiplied by the whole of this will be x to the power of negative 1 will still be 0. So the derivative of a constant is 0. So our final answer here is just what? 24 x to the power of 2 plus 1, and we are done. That's it. Now let's look at the next example. I hope that's well understood. Let's look at the next example here. Now we have x to the power of 7 minus 3x to the power of 6. Same thing. We do the same thing for this. We differentiate this rather as an entity, each of them as an entity. So if I'm to differentiate x to the power of 7, I'm using this particular first one here, which says what? Which is what? Just that will be 7, right? 7 x to the power of 7 minus 1, right? Minus, in the case for this, I multiply my exponent by the constant, the multiplier here. So that's 6 by 3. So that's 3 by 6. Then x to the power of 6 minus 1. So my answer is simply what? 7 x to the power of 6 minus 18, right? X to the power of 5. And that's our final answer. This is the derivative of this. Now let's look at the last example here. The last example here says x plus 4 all multiplied by x plus 2. In the case for this now, it is advised that you first multiply this bracket out, get an answer before you start doing the derivative, because if you are to use another method to do that for power rule, it won't work. It won't work at all. It will not work. So let's quickly do that now. So if I'm to multiply this out now, I'm using I believe you know how to expand a bracket already. X by x is what? X squared, right? X by 2 is what? Plus 2x. 4 by x is what? Plus 4x. 4 by 2 is what? Plus 8. So I have x squared plus 6x, then plus 8. This is the expansion of this bracket. Now let me now find derivative of the expansion of the bracket. So this becomes, remember that I'm treating it as an entity, each of them. So if I'm to treat this as an entity now, this becomes what? 2x, I'm talking about this, 2x, then I have 2 minus 1. Then plus, remember that there is an invisible 1 here, even if I'm not writing it. So it becomes what? 6 by 1, then x to the power of 1 minus 1. And remember what I said just now, I've established that differentiation of a constant is 0. So I can just write plus 0. So my final answer here now becomes what? 2x, right? 2 minus 1 is 1. Then plus 1 minus 1 is 0. So this is 6 x to the power of 0. So that simply, x to the power of 0 is 1. That simply gives us what? 2x plus what? 6. And that's our final answer. Make sure to like, comment, subscribe, and see you in my next video. Bye.